Hey everyone, I'm Shah. In this video, I'll walk through a real-world use case of crafting an ideal customer profile using AI. I'll start by describing what an ICP is and why it's important, and then go through this use case step by step with example Python code. So before talking about any of the technical AI stuff, let's just start with the business side of this use case and answer the question, what is an ICP? ICP is short for Ideal Customer Profile, and it's simply this idea that we might have a diverse range of customers that pay for our product or service, but there exists a subset of these customers that make up our best customer. Best in this case can mean many different things. Maybe they're the best because they have the greatest lifetime value. They might be the best because you really enjoy working with them. They might be the best because they always leave 5-star reviews or they give you a lot of referrals. How you define best will depend on the business context, but some things you might include in an ICP are things like the role that the customer has, the company size, goals, pain points, psychographics, demographics, and so on and so forth. There doesn't seem to be a single formula that this is all the boxes that you need to fill in for an ideal customer profile, but these are just some examples of things you might include. An ideal customer profile is just a description of our quote-unquote best customer, but why should I care about this? Why is this important? This is actually something I've learned the hard way, because when I first launched my AI cohorts, I didn't really have a specific customer profile in mind. I was just saying, hey, this is a 6-week cohort on AI and you can take it and we'll build projects and things like that. And it wasn't really targeted toward anyone. And this turned out to make my life a lot harder when it came to actually marketing and selling the course. Having a very clear idea of your ideal customer profile is going to be the foundation for the positioning, the marketing, and the messaging of your product or service. So an analogy I like to think about here is that when you're trying to sell to multiple customers, your marketing and sales efforts are kind of like a dull arrowhead. This might make an impact and get some people's attention, but it's not going to be as effective as an arrowhead that looks like this. And so this is what your marketing and sales efforts look like when you try to reach only a single customer profile. And then when you try to reach only your ideal customer profile, your marketing and sales looks a lot like this arrowhead here, but also it'll be raining stacks of money. Now that we know what an ideal customer profile is and why we should care about it, let's walk through how we can use AI to craft an ideal customer profile. Again, this is a real use case with real data from my AI Builders Bootcamp. All the code and data is available at this GitHub repo. Of course, I had to remove a lot of personally identifiable information, so not all of the raw data I used is going to be in the GitHub repo, but I have the final data set that I used there, so you can check that out. And of course, all the code I used is freely available as well. So I have a bunch of student data, things like job title, the company, why they joined the course, and the source, like where that student came from. So the way I defined ideal in this use case is basically students that left a 5-star review. The idea is that I'm going to use all this student data, like their job title, the company size, why they joined, where they came from, and I'm going to use that information to predict the probability that someone will leave a 5-star review, and then we can use that model to craft the ICP. Here's the workflow that I went through. The first step is the data prep. This was basically taking data from its raw source because I had to manually download a bunch of different CSV files from all the different cohorts and then clean them up and merge them into a single CSV file. Then I did some feature engineering because a lot of the data I have here are like job title or company name or join reason, which is all open-ended text responses, which you can't really do math with to predict the probability that someone leaves a 5-star review. So I had to structure this unstructured data, and I did that in a few different ways, as we'll talk about. Once I had the features in a structured format, I could train a logistic regression model to predict the probability of a 5-star review. This is just traditional ML here. Then I analyzed the results, so looked at the coefficients to see which features had the greatest impact on the probability of leaving a 5-star review. And then finally, I synthesized a lot of data, gave it to GPT, and had it construct the ICP for me. So the first step is the data prep. This consisted of 3 main types of data. So I had student data, which included their background, their join reason, and source. This was across 5 different CSV files for 5 different different cohorts, and then I merged all of that into a single CSV file called students.csv. Then I have this activity data, which is basically how engaged each student is in the course, how many modules they viewed, how many projects they submitted, how many times they clicked on a Zoom link to join one of the calls. So I have 4 of these, and I merged that into a single CSV as well. And then I did a similar thing for review data. So this is just customer feedback, includes like public reviews and how many stars they gave the course. And the reason I have 4 cohorts here is because at the time of recording this video, I am in the middle of cohort 5. So this analysis will only be for the first 4 cohorts of this course. So I won't walk through the code to do this here because it's quite long and not central to the analysis. But if you're curious on how I did this, it's all available at the GitHub repo linked here. Now that we've cleaned up the data, we can start doing feature engineering. Here there are 4 main variables that I want to do this analysis with. The join reason, so why they joined the course, which is this open-ended text response, company size, the job title, and then the source, so where that student came from. We'll start with the join reason. So again, this is unstructured text responses. So things like, I would like to get practical experience in building and deploying AI applications. I have some grounding in the basics, but I want to be able to get to the point of actually deploying apps. I would like to start to have a grasp of how I can use AI to build products. 2 things: build AI apps, ship a prototype, up-level my knowledge, gain hands-on experience, and so on and so forth. But the thing is, we need to turn this into a numerical representation so we can train the logistic regression model, because the logistic regression model can't work with text directly. The way I did that is in a few steps. The first thing I did is I gave all the join reasons to ChatGPT to summarize, to basically put into like a standard format. And the reason I did this is because the next step is I passed the summaries to OpenAI's embedding model. So I tried it without the summaries and with the summaries, and I feel like with the summaries gave me more reliable results. And then once we have the embeddings, I clustered the data using k-means. I'm just showing it on a 2D plot here, but in reality, the embeddings have over 1500 dimensions. You can imagine we're doing these clusters in this like 1500 dimensional space. At the end of this, I have assigned 1 of 5 clusters to each of the join reasons, and then I can do some kind of one-hot encoding to those clusters to turn these join reasons into a numerical representation. I initially tried this without the clustering. I just used the embeddings directly, but the problem with that was it was hard to interpret what the embedding dimensions actually meant. But by putting the responses into clusters, it was actually a little easier to do the analysis, as we'll see a little bit later. The next feature is company size. So here I wanted to take these unstructured company names like Google or Microsoft or self-employed or wherever the student works at, and categorize the company size into one of 3 groups. So either self-employed, so solo, SMB, small to medium-sized business, or enterprise. The goal here was to take these unstructured company names and turn them into one of these 3 categories. While there are many ways we could do this, here I went with a large language model. So the input was just the company name, give it to an LLM, and then have the LLM categorize the size. While this might work well for very well-known companies like Google, this won't work well for self-employed people like me or small to medium-sized businesses that may not be super well known. So the LLM won't know how to categorize my company based on its pre-training data. However, if we give it access to a web search tool, then it'll be able to search the web to find the publicly available information about my LLC. It was actually pretty easy because OpenAI has this web search tool that you can use. Basically, you can just add an argument to your API call that allows the LLM to use a web search tool. So this actually works surprisingly well. The only thing to keep in mind is that the web search tool can be quite expensive because it's calling this function and then processing a lot of tokens. So this actually got pretty expensive for like the 100 students I was looking at here. It would cost me a few dollars to generate these size categories. Once we have these size categories, so we'll have either solo, SMB, or enterprise for each of the students, and then we can translate these into a numerical representation via a one-hot encoding. The next key feature is the job title category. So here I had a handful of different categories. So I had IC, leader, manager, student, or entrepreneur. The way I generated this is I took the job title, like founder, data analyst, analyst, VP finance, head of product, data scientist. I also took the size category that we just computed with the LLM and the web search tool. So like founder solo, data analyst enterprise, VP finance enterprise, head of product SMB, and so on and so forth. Then I gave all this information to GPT 4.1 and then had it come up with a job category. This one was entrepreneur, IC, leader, IC. So this did a pretty good job as well. And it was much cheaper because it didn't need to use any kind of web search tool to figure this out. And then the final feature, which is going to be the simplest, is the source. So there are various sources that come from Maven, which is where I host the cohort. Maybe they came from the waitlist. Maybe they came from a lightning lesson, which is like a free webinar. Maybe I enrolled them for free. Maybe they went to the landing page directly and just paid for the course. So that's what started payment is. And so for this, there's no need for embeddings or LLM calls or anything like that, because these are going to be discrete categories. And then we can just directly do the one-hot encoding for the sources. This is actually what I did for the join recent clusters, the company sizes, and the job categories. I come up with these discrete categories, and then I do the one-hot encoding, basically giving a column to each unique category. For example, these first two are on the wait list, so they will have a value of 1 for this source waitlist column. This person came from the lightning lesson, so they have a value of 1 in the source lightning lesson column, but then 0 for all the other columns. Even though I didn't show any of the code in the slides here, it's all available on GitHub, so you can check it out there. But now that we have our data all ready to go, we can train the logistic regression models. The first thing I did was define the predictors I want to use. So the predictors I went with were the job categories. So they were entrepreneur, IC, leader, manager, student, or it was unknown. These were all encoded. The source, so enrolled for free, lightning lesson, started payment, uploaded to waitlist, or they came from the waitlist. And then finally, we had 5 clusters for the course join questions. I didn't end up using company size directly because it didn't seem to have a very large impact on the model, and the models performed better without those variables, so I just dropped them. But company size was used to generate these job categories, so it is indirectly used in the model. I actually trained 2 separate models. I had one model for if the person left a 5-star review, so I have this variable which is just true false if they left a 5-star review, and then I have another column which is just a true false if they left a review at all. Once we've defined the targets, we can do our training and testing split. So here I'm using this train test split function from the scikit-learn library, and I'm using 70% of the data for training and 30% for testing. Next thing is I train a model for each target. So the way I do this is I initialize this dictionary, and then I have this target list, which we saw in the previous slide. So one is rating exists, the other target is rating greater than or equal to 10. And then we just go through this loop one at a time. So for the first target, if they left a review, we'll pick out the training and the testing data, and then I'll train this logistic regression model. Since most people didn't leave a review, this is going to be an imbalanced data set. So we can use this class weight argument to add sample weights when training this logistic regression model. And then C just controls the strength of the sample weights. Here, a lower C value means we're making the data set more balanced using the sample weights, and then a higher C means we're leaving the data set as it is. And then we can just do this fit method. So we have our training inputs, we have our training target, then this will create our logistic regression model with just one line of code. And then we can add this model to our CLF dictionary. So I'm creating a new key value pair where the key is the target. So this is rating exists, and then this will be the first classification model. And then we'll go back up here and then do the same thing for the next target. Doing it like this makes it easy to train like 10 different models and then do analysis with it later on. But here I just ended up using 2 models. Here are the results. I'm showing the accuracy of each model, the AUC score, and the F1 score. And then I also have like a delta between the training and testing for each of these. And so the main thing I was looking at is the F1 score, because this takes into account the imbalanced data set. It doesn't do an amazing job, and I think one of the issues is that I only have like 92 records in this data set, but there's definitely some signal, so it's better than chance. The accuracy is like 75%, and the training and test F1 are pretty similar. The main artifact from this logistic regression model that I was looking at are the model coefficients, because this is going to tell us the direct relationship between each input variable and the target variable. So basically here, the negative coefficient values, so these ones in red, are telling us that these variables have a negative impact on the probability of someone leaving a 5-star review. And then the positive coefficients, so the blue ones here, mean that these variables have a positive impact on the probability of leaving a 5-star review. Analyzing this, the most striking thing is that if someone is an individual contributor, that significantly increases the probability they leave a 5-star review, while if someone is a leader, that significantly increases the probability that they leave a 5-star review. Here we're starting to suss out who is the ideal customer and who is not the ideal customer as defined by leaving a 5-star review. Another one is people that were uploaded to the waitlist. Before I decided to do this course on Maven, I had a landing page on my website for it, and I had a place where people could sign up for the waitlist. And so there I had like 50 people sign up to that waitlist, and then when I decided to move over to Maven, I manually uploaded these 50 people. So the people that were eager to sign up for the course right when I first announced it are going to be these uploaded to waitlist people. Job category unknown, so basically they didn't fill in their job title. That has a negative impact on leaving a 5-star review, and this might just be because they are not the kind of person that wants to fill out forms on Maven. They just sign up for the course, they didn't want to put in their job title, and then they don't really care about leaving reviews or doing anything extra beyond the coursework. Job category student, job category entrepreneur, enrolled for free, so that's a strong negative impact. And then this one's interesting. So course join question cluster 4 also has a positive impact. This isn't directly interpretable, so what we're going to have to do is print out all the responses in cluster number 4, and then we can start to find patterns or just give all of these to GPT, which is exactly what I did. So even just from this, we're starting to get a sense of who the ideal customer is and who the ideal customer isn't. It tends to be the people that are leaders, highly engaged with my content, students, entrepreneurs, and it tends not to be individual contributors, people who are just not engaged with the platform, and the people that were enrolled for free. The great thing about looking at the coefficients is that it gives us clues of where to look further. Job categories tended to come up a lot in those top predictors. So I made a table like this that's showing the job category here and also showing how many people in the entire data set fit that job category, the percentage, and then various different KPIs. This first one is if they submitted 3 or more projects. So this is like an engagement metric. This is how many people left a review, and then this is how many people left a 5-star review. First, looking at individual contributor, which was that first variable that had a very negative impact on leaving a 5-star review, we can kind of see why, because these people, they submitted the least amount of projects. So only 15% of them submitted 3 or more projects. Only 27% of them left a review, which is actually the smallest out of all the different job categories. And then only 12% left a 5-star review. So only like half of those who left a review left a 5-star review. This is kind of like the worst job category, which aligns with what we were seeing with the logistic regression coefficient plot. On the other hand, if we look at the best performing KPIs, we see entrepreneurs tend to be very engaged. 44% of them will do 3 or more projects. 56% of them will leave a review. And then we have leaders, which are a strong second, where 53% of them left a review. And then 100% of the leaders that left a review also left a 5-star review. And then most of the entrepreneurs leave a 5-star review. So we're already seeing that like entrepreneurs and leaders tend to really like the course. They tend to be the most engaged. Leaders aren't as engaged, and I'm sure that's just because they're busy, or maybe they're not really doing it for the technical things. They're just trying to get a high level understanding so they can lead initiatives and lead teams, but they're not actually building products themselves. And then I actually created similar tables for like the source and the join reason cluster. I won't go through it here, but all of it is available at the GitHub repo. Another thing I created was, instead of splitting the job categories by KPIs, I split the job categories by company size. And it turned out a lot of the leaders were also from SMBs. So they were probably entrepreneurs at some point, or they're still entrepreneurs. They just have a few employees now. So they're more focused on leadership and management as opposed to like maybe building products themselves. Another thing we saw in the coefficient plot was that if the join reason was cluster 4, that had a positive impact of leaving a 5-star review. But now we need to interpret what that means. We need to try to find patterns in the the join reasons. So one thing I did is I formatted all the join reasons in Markdown. Once I had in this Markdown format, I could give it to GPT and ask it, what are the key differences between cluster 4 and all the others? And so I just created this function that abstracts the sending a request to OpenAI's API. I had this question, and then I sent this Markdown file as an input, and I got a response. Then I saved this response in a Markdown file. So this is something that we can use later in crafting the ideal customer profile. And the last step is actually constructing the ICP. Here I loaded two things. We have that cluster analysis, which we just talked about on the previous slide, but then I also got an extract of all the customers that left a 5-star review and formatted their responses and data in this Markdown table. And now we can use both of these when constructing the ICP. Here I'm having GPT create the ICP for me. And so this is the prompt I used. Here I have a title, ideal customer profile generator. Your task is to generate an ICP for the AI Builders Bootcamp using the following information. And then I have this header, who is the ideal customer. The best customers are technical entrepreneurs. They run a small to medium-sized business ranging from 1 to 150 employees. So they're either solo or SMBs. They know how to code and typically have 7+ years of experience, but they are new to AI and large language models. Who is not the ideal customer? Individual contributors are less engaged in the course because they, 1, typically already have enough coding projects to work on, and 2, probably don't have as much to gain/lose compared to technical entrepreneurs. There's a similar story for managers. And then I gave that additional context of the 5-star customer data and the cluster analysis. Notice here I'm combining 3 types of context. One is directly giving the model data from 5-star customers. The second is giving it the cluster analysis generated by GPT. And then finally giving it my insights and my interpretation of who the ideal customer is. This is generated from looking at the tables from the previous step, looking at the coefficients, also just all the context I have from running these cohorts. And then the final result is the ideal customer profile. Got it open over here. It included things like background and demographics, role, technical entrepreneur, business size, technical experience, AI LLM experience, goals and motivation, primary goals, build, deploy, and optimize real high-value AI and LLM-powered systems from scratch, acquire end-to-end knowledge, make informed technical decisions, identify and implement high ROI solutions, key motivations, need to ship real custom AI apps, desire to turn emerging AI LLM capabilities into genuine business leverage, want hands-on experience beyond mere theory or generic upskilling, looking for support, expert guidance, and a peer community, pain points and triggers, uncertainty around where to start with AI and LLMs, frustrated by overly generic or shallow courses and resources that don't have hands-on production-grade AI system design, need to justify spending investment in AI, requiring clear understanding of real-world value creation, then unsure about the practical pros and cons of different technologies and best practices of robust deployment, who's not the ideal customer, ICs, managers, beginners, psychographics, builder mentality, outcome driven, and then it included some 5-star review excerpts, and that has like a nice summary at the end. The great thing about this is that now, anytime I want to write a landing page, a LinkedIn post, a newsletter, whatever it might be to promote the course, I can just feed this as context so that GPT knows how to improve the messaging, because I don't know anything about copywriting. I'm just learning all this as I go. So I do rely heavily on ChatGPT to do copywriting for me. Takeaways. First, I think this is probably the biggest thing, is using AI LLMs to structure unstructured data. Here I actually did that in 3 different ways. First is just giving the data to an LLM to have it classify it. So this works well with easy categories like a job title. The second way is to have an LLM with tools classify it. So this is better for like hard categories. So the example we saw here was the company size, where it needs to do a web search to classify the solo companies and SMBs, the companies that the LLM would not know about from its pre-training. And then finally, using embeddings and then clustering those embeddings. So this is helpful for no clear categories. So I use this for the join reasons. And an important note here is that using the embeddings directly is going to be hard to interpret down the line, but by putting them into clusters, we actually have a chance at interpreting them, because we can just look at that specific cluster. Like we looked specifically at cluster 4, and then we can also give all the clusters to GPT to do some kind of analysis to compare the cluster that we care about to all the other ones. sense. The second takeaway is that there's still a place for traditional machine learning approaches. Today, everyone's so focused on large language models and people just try to do everything with LLMs, but they're not so great at working with numbers. And when you have some clear KPIs that you're trying to optimize for, like someone leaving a 5-star review, you probably don't want just a qualitative analysis. You want a more quantitative analysis, which is what you can get from techniques like logistic regression and other traditional machine learning approaches. And finally, the ICP is going to be really good context for an LLM when having it do copywriting, writing newsletters, doing LinkedIn posts, or whatever it might be. So I hope this video was helpful. It was a bit different than most of my other videos, which are more focused on technical concepts. This one was more about this actual use case and how we can use the technologies and how we can use AI to solve this particular use case. If you like content like this and you want me to do other real world use cases and you have any suggestions, let me know in the comment section below. And as always, thank you so much for your time and thanks for watching.